I modified my tailstock a little bit. I replaced this screw which held the clamping plate. Now this one would come undone quite often, I think due to vibration or something like that. So I had to remove the tailstock and get it to a position where I could access the screw, usually at the rear, and reset it for the correct distance. But I wanted to fix that, so I put a stud in, threaded stud. It's actually a large set screw, cut to size, and then I locked it with another nut. I thought about Loctiting it in place, but I would rather not do that because it's quite difficult to remove it if something goes wrong while it's clamped to the lathe bed. It's very difficult to access it. So this one might be better. But I can always undo this part by removing the handle. So, now this is the clamping mechanism. And I've adjusted it so it would clamp at the maximum height of the cam inside. Here's the top slide. It has a indicator for the angle you can set with the compound. But this is just a plastic ring, and there is no registration mark here. So I took the holding disc and I used a center finder to scribe a line, and then transferred it to the side, and then with a square I align it as good as possible to this side, and made a mark here. Now I can transfer the mark to the place where the actual dial is. So now I have a registration mark, and if this one doesn't check out, if I'm making all the adjustments to it, then I can move this one a bit side to side, I think, to correct for the angle. So with the installed top slide, if I set its angle at 90 degrees from the cross slide, and then I don't know if you can see this. Mark doesn't read exactly 0, but I think this mark is better than the plastic ring. It reads a bit under 2 degrees. I will have to check it when it's installed on the lathe. In the first part of this series I showed this view, the electronics at the rear. And what I actually didn't know then was that this back cover is just a piece of paper. I decided to open it up and check the inside. And this appears, this is just paper with a bit of plastic coating. And there is a plastic rim around the base of the circuit board, which is actually a good thing. Chips can't go under it, but it's not located properly. There's a tiny gap here, so I will fix that, and Here it's how it's supposed to be. But I just wanted to check this, and I found this out. I think I'll make a plastic cover for it. There's one more thing I want to check, and that's connection of the headstock to the bed. When I disassembled the lathe, I found out one of the bolts wasn't tight enough, and I can only reach two of them without removing this electric housing. So I have to remove this to access the other two. But I've checked, and I can't disconnect the wire from the potentiometer. There's an extra wire crimp to it, and I can't undo it easily. So I will cut these wires here. I will remember the order they're in, blue, brown and black, and then solder them on later on. Here's a close-up of the safety switch connected to the truck cover or the chip guard. It feels like a steel cylinder with a flattened end. When turned, it presses a switch. And I think it's held in place by a set screw. This is a plastic block, and I think I can modify this to make an extended cover for when I use my forge jaw. It's one of the things I want to modify. And I made a problem. I broke the switch which is mounted here, and it's a safety switch which disconnects the power when the cover is removed. And this plastic is kind of brittle, and it broke when I tried to remove this one from the plate. I have to fix it, get a replacement, or even try to glue it, but I don't think that's a very good idea. I just want a good switch in there. Here are the bolts on the inside. I checked them, and they were tight. Couldn't get any movement. I cleaned the circuit board. There was a layer of oil or grease on it, or maybe some WD-40 residue. I used circuit board cleaner, and here's the underside, the covering plate. The circuit board doesn't match the holes in the plate, so I used a Dremel to get the holes to fit. And the real shape of the hole doesn't, the shape of the holes doesn't matter that much. It's screwed down to this metal. I found another issue. The saddle is held on the bed by two clamps. It's secured with 3 screws on each side. But when I tighten these properly, the saddle is really tight on the bed, and I can't easily move it anymore. So I have to put some shims between the strips and the saddle to adjust the clamping force properly. I made some brass shims. These are made from 0.05 millimeters brass foil. It's the thinnest foil I could find, brass foil. I hope it gives me enough room for adjustments, and I hope I don't need anything smaller. I used a piece of clear plastic to drill into to prevent big ripping effects. And it's easy to align the strips along the edge of the relieved side of the metal strip. So I now can try fit the metal strips to the lathe. I already did some testing, and maybe one piece of brass is enough for the rear, and maybe one or part of 2 strips is what I need for the front. Here's the saddle. I wanted to reassemble it, but I ran in another problem. First, these surfaces on the underside, which ride the lathe bed. They don't seem to be really smooth. They appear not to have a nice contact surface. But these clamps hold the saddle down on the lathe bed. And I'll show you a picture from about how they were before. And as you can see, the sides of the clamping surfaces are a bit worn out or not perfectly straight. A while ago I tried to improve the state of my lathe a bit, and I smoothed out these surfaces which touch the underside of the lathe bed. But I think in process I didn't have a proper surface plate, so I think in the process I kind of messed up the plane of the clamping surface. So now the surface is out of plane and it won't make proper contact anymore. And I was about to shim the strips to the correct height on the saddle. I made some brass shims. I can show them. So I made a few shims to adjust the space between the clamping strip and the underside of the saddle. This is 0.05 millimeter brass foil, and I just cut a few strips and drilled a hole between two other materials to prevent tearing and burring. But I didn't get the result I wanted. I didn't have enough ways to adjust. I mean, the thickness, it's too thick. I still needed tinier adjustments. And there was one point where my lathe, where the saddle kind of caught riding the lathe bed. So there was also a problem there, and I was wondering about it and what I should do. And in the end I decided I would just start over with these. I went to a friend and with his help I resurfaced these strips, and I didn't know what original distance between these two between these two planes was. There's a step in here. But I chose the nearest whole number, or the nicest number. So at one of these strips the step is 1 millimeter, and on the other it's a half. And that's maybe a easy thing to work with. But the most important thing is that now these two planes are parallel. And the way they were, I think, was that one plane was a bit out of parallel, like twisted and rotated. So I'm gonna smoothen these surfaces out a bit. Now I do have a surface plate, and I will use some oil and fine sanding paper. Grit 600 and then maybe 1200 to get a nice smooth surface, because there might be a bit of sharpness in here, although I can't feel it. The surface actually looks quite good. I think it's better than the surface I can obtain with the normal mill I have at my disposal, which I couldn't use in this occasion. It's out of running, sadly. But now I will continue with these strips. Here's my small surface plate. A piece of this is 400 grit. I think I'm out of 600, so I really need to order some of the finer grits. I put some oil on it. This is a wooden rim I made for it to it can fit a cover, or it holds the sanding paper in place. And let me spread this out a bit. Unfortunately, the side I want to smoothen is the highest. I mean the plane is sticking out of sticking above the other. Now the important thing is to hold it really flat. Otherwise, the same would happen as what happened before. I may need a bit more of this stuff. Just cotton oil. From what I learned, the best way to do this is making figures of 8. If you do circles, you are more likely to put more force in one side of the rotation, so the sanding will be a bit less even. I did a bit at a 320 paper, and this is 400 again. The process isn't as even as I hoped. The center part still has some cutting marks in it. I tried to deburr it, but got the edge accidentally. But here in the center, I hope you can see it. Maybe it can catch light. There's still a track of cutting marks here, and the other sides are cleaned up already. So I will just continue with it. Second one, 400. Here's the top slide gib. And as you can see, these sides don't make contact. They can be adjusted, so maybe it's just a matter of adjusting, but the best thing would be one level surface. So this one needs some work too. I already tried it on very coarse sanding paper, but that's not helping either. So this one is going to need a lot more work, but I'm not gonna do it now. There's a cross slide gib. And this one looks a lot better. Although I can see long scratches along the surface. But fixing that will have to wait. I found another issue. I was adjusting the clamping strips on the bottom of the saddle. And as you can see, the saddle kind of grips around this area. It's not secured at the back at the moment, but there is movement on this side and on this side. So there's an unevenness in the bed, and I don't know if it's because of the way it's positioned or just the shape of the bed. And I really have to look into it, and I decided not to hasten the reassembly of the lathe.